In this lesson, we're going to continue to look at special right triangles, but we're going to take a look at what happens when you're not given your short side. In the previous lesson, we dealt with solving right triangles when you're given the small side. Again, sometimes you're not always given that side, so we're going to talk about that kind of scenario in this lesson. To recall, a 45, 45, 90 triangle. You have two 45-degree angles. The legs are always going to be the same. And again, we're just representing both sides with n. It's just representing a number. To get the hypotenuse, you take whatever your leg is, and you write radical 2 next to it. And a 30, 60, 90 triangle, one angle is 30, one angle 60, and the other angle is 90. On your short side, the side across from your 30 goes your main side, a number. And then you take whatever your short side is, and you're going to multiply it by radical 3 to get your long side, the side across from the 60. And then to get your hypotenuse, you're going to take whatever your short side is, and you're going to multiply it by radical 2. It's really important, as you can see here, always find the short side first. And we're going to find the short side by dividing whatever long side you're given. And again, we're going to go over that process here in the next few examples. Okay, but think dividing when you're not given the short side. So this is written at the top of your paper. I'm just going to refill it in here. You don't have to rewrite this, it's already at the top, but just so we can reference it a little bit better. So, in this first section, we're going to talk about 45, 45, 90 triangles. And when we solve these triangles, we're going to find all of the missing parts. So one, we know it's a 45, 45, 90, so we're going to fill that in. And this time, in the last lesson, we were given the legs, and we just filled out the rest of our triangle using our diagram. We're not given the legs in this problem. We're given the hypotenuse. So when this happens, when you're not given the legs, you're going to take whatever part you're given. So in this case, you're given the hypotenuse. So I'm going to write it down. 8 radical 2. Okay, 8 radical 2 is our hypotenuse. You're going to look at your diagram, and you're going to set that equal to whatever is written in that same spot in your diagram. So 8 radical 2 is the hypotenuse. Go to that diagram, and radical 2 is the hypotenuse. So set them equal. And then you're just going to solve for n, and whatever you get as your answer, that's going to be what your legs are. So, to get n by itself, we're going to divide. We're going to divide by radical 2. That way it's gone. It's really nice because radical 2 divided by radical 2, those cancel out. And we're just left with n. Same thing happens here. These radical 2's are going to cancel out, and we're just left with 8. I know we just solved for n, and the variables here are u and v, but that n just represents whatever your leg is. So we got 8. That means v is going to be 8, and that means u is also going to be 8. That's just representing our legs. Same thing with number 2. And number 2, we weren't given our legs in this 45, 45, 90 right triangle. We were given our hypotenuse. So you're going to take your hypotenuse, which is 4, and set it equal to the hypotenuse in your diagram, which is n radical 2. And then you solve for n. Well, to solve for n, again, we're dividing. And we're dividing by radical 2. That way it cancels. cancels. We're just left with n. And then we have 4 over radical 2. Really tempting just to plug that in our calculator, but if you notice, we want our answer to be in simplest radical form, so it says in the directions. Okay. There's a shortcut to simplifying this. Normally, when you have a radical in the denominator, you have to multiply the top and bottom by the radical, and then simplify. It's a lot of work. So there is a shortcut to this, so we're just going to focus on doing the shortcut. Whenever you have a radical in the denominator, what you can do is kind of ignore the radical. You're just going to do 4 divided by 2, which is 2. Okay? And then you just, whatever radical's in the denominator, you're going to write next to that. And there's your answer. We're just going to focus on the shortcut and simplifying. Okay? So that means that's what you got for your leg. So x would be 2 radical 2, and y would also be 2 radical 2. That n is just representing whatever your legs are. Okay. And one more. Again, we're not given the legs, we're given the hypotenuse. So you take your hypotenuse, set it equal to the hypotenuse in your diagram, and solve for n. Well, to solve for n, we just divide by radical 2, and you might be noticing a pattern. Cancel out, and we're left with n. Use that shortcut we talked about in problem number 2. Okay, well, 7 divided by 2 is not divisible. You can write it as a decimal, but we want to try to keep things as fractions. So 7 over 2 cannot simplify. So we just leave it as 7 over 2. Whatever radical is in the bottom, the denominator, write it next to that number. So again, the shortcut, whenever you have a radical, you just take the top and divide it by the number underneath. So 7 divided by 2, you can't do that, so we just leave it as 7 over 2. Take whatever the radical is in the bottom, which is radical 2, and write it next to that number. Good. Whenever you get, that's representing your legs, so it is just 7 radical 2 over 2 radical 2, 7 over 2 radical 2. So you might be noticing a pattern. If your legs are missing, all you're essentially are doing is you're just dividing whatever the hypotenuse is by radical 2 and then simplifying. If you recognize that shortcut, go for it. If not, just set up your equations and solve. Then I'm going to move on to the next set of examples, so if you need to pause, you can do so. Okay. In the next section, we're going to talk about 30, 60, 90 triangles. I'm going to refill out that diagram. It's already on the top of your paper. We have 30, 60, 90. The side across from your 30 is your main side. The side across from your 60 is just n radical 3. The side across from your 90 is just 2 times whatever your short side is. So problem number 4, we know this is 30 degrees, 60 and 90. Always want to start with our short side. That's super important. So we start at our 30 and go across. We have a variable. Right? In the last lesson, we always had a number there. We just filled in our diagram using that number. The problem is we don't have a number this time. So when that happens, you're going to go to whatever side you're given. So here, we're given a 10. Okay? So you're going to go to that side. Write that down. Equals 10, and this problem is the hypotenuse. So you're going to go to your diagram. The hypotenuse in our diagram is 2n. So I'm going to set that equal to 2n. we just divide to get n by itself. So we get that n is equal to 5. Whatever you get, that's representing your short side. Okay? So we just got that our short side is 5. Once you have your short side, we're going back to what we did yesterday. You just take that number and you fill it into the rest of your diagram. So we already know what our hypotenuse is. We just need to know what our long side is. So again, if you look at your diagram, the long side is just n radical 3. Well, that becomes our long side in this one's going to be 5 radical 3. Just take whatever your short side is, and you write radical 3 next to it to get your long side. Okay. And then for 5, we have a 30, 60, 90 right triangle. Okay. Go to your 30. Go across. We're going to do that first. And this, again, we're given a variable. Okay. So go to whatever side you're given. You're given 12. 12 is our long side because it's across from the 60. Okay, so you're going to go to your diagram. Well, the side across from the 60 is n radical 3. So we're going to set that equal to n radical 3. Solve for n. So we divide by radical 3. Divide by radical 3. Going to use that shortcut we talked about in that previous section. Whenever you're dividing by a radical, just do 12 divided by 3, which is 4. Write the radical that's in the bottom. Okay. And again, that is representing your short side. So our short side is 4 radical 3. Once you have your short side, you're just filling in the rest of the diagram. So we get our hypotenuse. It's 2 times whatever you got for n. Okay, this time we got n is 4 radical 3, and that's okay. Sometimes that happens. And when we multiply those together, 2 times 4 is 8 radical 3. Don't multiply the radical by 2. Just multiply those two numbers, not underneath the radical. Write the radical after the number. And there you go. Number 6. Again, very similar. We have a 30, 60, 90. Always start at your 30 and go across. And we're not given that side, so we have to figure out what it is. Well, I was given 11 radical 3. 11 radical 3 is the side across from the 60. So go to your diagram. Side across from the 60 is n radical 3. Okay. Divide by radical 3 to get n by itself. Radical 3's cancel. And again, it's really nice because these radical 3's cancel, so we're just left with 11. Again, that's always representing your short side. Once you have your short side, you just kind of do what you did in the last lesson. Find our hypotenuse, it's just 2 times whatever n is, and 2 times 11 is 22. So kind of to sum things up with a hypotenuse. Given, not missing. When the hypotenuse is given, you're going to divide by 2. Whenever you're given the hypotenuse of the 30, 60, 90, you're going to divide by 2. Whenever the long side is given, you are going to divide by radical hypotenuse is given, you're dividing by 2. Whenever the long side is given, you're going to divide by radical 3 to find your short side. So that's the side you always want to find first.